All right, folks, it's Bass Action back in action here. On this video, we are going to look at some examples using both our midpoint formula and our definition of midpoint. We're going to also combine in our segment addition postulate from the previous lesson. Okay, before we get too far though, depending what version of this handout you have, I want you to make a correction to number 3 here. I need you to change HU and UB to be what is shown here if yours doesn't already say it. If yours already says it, then obviously you are good to go. So if you need to, pause it, but get that changed, then we're going to go back up to the top. Okay, so up here at the top, we're going to start with what we would do with our midpoint formula, what we would do when we had ordered pairs. So this is specifically the process that you'll use when you have an ordered pair in our coordinate system, okay? Again, as I mentioned before, try not to worry too much about the actual formula per se and focus more on what this formula is having us do. It's an average of the x values and an average of a y. We need to do it twice because ordered pairs have both an x and a y coordinate. So on our first example here, we're given 2 ordered pairs and we're told that they are the endpoints, and we're specifically told to find the coordinates of the midpoint. Okay, so we're asked to find this midpoint, so it's not any big deal at all. We can actually just jump right into our formula if we want. So we would have our -60. I'm going to add those x coordinates, -60 plus a 13. It does not matter which point you call point 1, which you call point 2. I'm going to take my 203 and I'm going to add the -19, which actually means to subtract 19. And I'm going to divide that by 2 because we're taking an average. I'm okay when you're working with midpoint if you go ahead and use a decimal. It's not that big of a deal to me. So if you go ahead and type this into your calculator, which you may need to do, depending on how comfortable you are with those bigger numbers, you would get a -23.5 and a 92 for the y coordinate. All right, so that's finding the midpoint. And what I want you to be able to envision is that that means that we had some segment, okay, we had some segment WE, and I knew the endpoints. I knew this and I knew this, and I added the x's to get the new x coordinate, and I added the y's to get the new y. That's important to understand because on our next example, instead of being given 2 endpoints, we're going to be given an endpoint and a midpoint and asked to find the other endpoint. Now, I've intentionally made these numbers kind of big and cumbersome so that you can't just count it out. I want us to visualize what's happening here. Again, I'm going to draw a picture. I'm going to give myself my midpoint. I'm going to label it so I can tell that I'm trying to communicate a midpoint. I'm going to put the endpoint I'm given on one of the ends, -60, 203. I'm going to put the midpoint on there of 13, -19. And then since I don't know the other endpoint, I'm going to label it XY. So now we're just working our formula backwards, and we will need to be comfortable working all of our formulas backwards in this chapter. So, or in this, really this whole course. So we're going to add these x values together, and then we know it has to equal this midpoint after we find its average. So I can go ahead and say x minus 60, because I'm adding the negative, divide by 2 equals my 13. Then I can multiply both sides by 2. Gets me a 26. I'm going to go ahead and add that 60 to each side. So I'm going to get an 86 for the new x coordinate. So the x coordinate of the other end should be 86. Repeat the process for the y. So I can say y plus 203. Divide that by 2. When I average those y values, I should get a -19. So y plus 203 is going to equal a -38. Subtracting that 203 from each side gets me a y coordinate of a -241. Putting that together, I'm going to write my ordered pair. Remember, has to be the 2 numbers separated by a comma, and it does need to have parentheses around it. Okay, so that's working our formula both forwards and backwards, so you're going to have to read those questions carefully. Now, on our next two examples, what we're going to do is we're going to use our definition of our midpoint. So we're going to draw some pictures. We're going to combine this with our segment addition postulate. Again, remember that you need to have the examples here that I have for HU and UB so that your problem will match mine. All right, so I'm told that U is the midpoint of HB. So I'm given this piece of information. It's not ordered pairs, which means I'm going to definitely draw a picture. So I'm going to go ahead and I'm going to draw that picture. Remember, if it is a midpoint, we want to make it look like a midpoint. We want to label it so it's a midpoint. U is the midpoint of HB. I'm going to label the things that I'm given. So it tells me that HU is x squared plus 8x. UB is 5x plus 54. And ultimately, I need to find the length of HB, so the length of the whole segment when I'm all done. What does this mean geometrically? I've already labeled it in the picture. We've labeled that. We know that HU is going to be congruent to UB because we were told it was a midpoint, and the definition of midpoint says it gets congruent segments. That means that we can set those two segments equal to each other and say x squared plus an 8x equals a 5x plus a 54. Since this is a quadratic, because I have that x squared, since this is a quadratic, I'm going to move everything to one side. X squared plus a 3x minus a 54. I'm going to factor. I'm looking for things that multiply to a negative 54 and add to a positive 3. That's going to give me an x plus a 9 and an x minus 6 equals 0. Our zero product property says that one of these factors, or possibly both, has to equal 0. So mentally, I'm setting this factor equal to 0, thinking x plus 9 equals 0. What does that mean? That means that x equals a negative 9, and then the other factor means that x equals 6. This means that I have two potential answers for my problem. So I'm going to first look at the x equals negative 9. So if x equals negative 9, okay, so if x equals negative 9, I'm going to come back up here to my original picture, and I'm going to take that negative 9 and I'm going to plug into either this segment or this segment, and they're the same. So I'm going to get for UB, I'm going to get a negative 45 plus a 54. So that means that my UB turns out to be 9, which means my entire segment HB is 18 units. Now, sometimes you'll plug a number back in, plug in a variable for x, and you'll get a negative measurement for the object. That can't happen, in which case you would reject that as a possible answer. We're also going to check and make sure that x equals 6 works, that we get an acceptable positive segment. So that means that UB is 30 plus 54. That means that UB equals 88, which means HB, the segment I want to find, is 176 units. Okay, so both answers would need to be given, or you would only receive half the credit. Okay, our last example is going to go much, much faster because there's not nearly as much happening here, so you might need to rewatch that example 3. But on our last example, again, I'm told that E is the midpoint of some segment. So I'm going to work again with that key segment, that key word. So I'm going to draw my picture, give myself my midpoint, my two congruent segments. E is the midpoint of WT. I'm going to start labeling. This time it tells me that the whole segment, WT, is 16x minus 6, and it tells me that one of the pieces is 4x plus 9. Now, what I know is that these two are not equal, clearly, because this is a whole and this is a part. But what I also know is that these two segments here are congruent. So I can either relabel this as a 4x plus 9, okay? And then remember my segment addition postulate that would say that the small part plus the other small part will equal the whole part. Okay, so now if you want, you can think of this as 2 times 2 times of this 4x plus 9, since it's going to be the same twice. Or you could go ahead and write 4x plus 9, substitute, and 4x plus 9. I'm going to jump to the faster way, and I'm going to go ahead and indicate this then as a 2 times 4x plus 9. And that's going to equal the whole segment, 16x minus 6. I can see that I can divide both sides by 2 here, so I'm going to say 4x plus 9 then equals 8x minus 3. Continue my solving, and I'm going to move my x's to the right. I'm going to get a 4x then. Move the 3 over. That's going to give me a 12. That gets me x equals 3. I'm going to go back up and see, what did I want to find? I was simply told to solve for x, so that means I'm all done. Okay? So there's a lot going on here. We're going to do some more examples and more practice in class, but start to get comfortable with combining our ideas.